Next question, determine the current drawn from a 12 volt supply with internal resistance 0.5 ohm by the infinite network shown in the figure. I have drawn the figure there. Each resistor has 1 ohm resistance. So you have to find out current drawn from the battery. The battery is connected here, 12 volt and 0.5 ohm. Volt battery voltage EMF. This is internal resistance. So in problem like this, which is infinite ladder network, you apply one concept. What is that concept? You find out which unit is repeated infinite times. In that, if one unit is removed and find effective resistance, the effective resistance will be same. Infinite network effective resistance will be same as infinite from the infinite arrangement. If you remove one arrangement, again effective resistance remains same, not getting affected. Use this point and you can do it easily. First, find out which unit is being repeated. You see this one, that is this forms one unit, repeated infinite number of times. These two are left out separately. So what we can do, first you want to find out effective resistance here. Infinity to here. Then you can add these 2 ohm with that. 1 and 1, 1 plus 1. Infinity up to this point, up to these 2 points, you want to find out. Then with that resistance, you can consider this 1 ohm and this 1 ohm after that. So from infinity up to this, say AB, now you consider it as C and D here. Infinity up to AB, same as infinity up to CD. This 1 ohm, this one unit is additional. So infinity up to AB you want effective resistance, which will be same as from infinity up to CD. You see between C and D, from infinity up to C and D, infinity up to A and B, only 1 unit extra, that's all. So from infinity up to CD, you call the effective resistance as R. From infinity up to CD, it is R. Then you have this 1 unit. Infinity up to C is here, D is here, then 1 unit additional. Then this 1 ohm, this 1 ohm. 12 volt, 0.5 ohm. These are all 1 ohm, 1 ohm. Now you can find the effective resistance between A and B, equated to once again R. Okay, these 3 in series, so 2 plus R. This 1 ohm, this one and this one. Now you see these 2 are in parallel, then in series with these 2 ohm. All resistors are in ohm. These 2 in parallel, so 2 plus R by 3 plus R for these 2 in parallel. And these 2 extra, these 2 are in parallel. No, first you finish off these 2. These 2 are in parallel. So 2 plus R by 3 plus R. That should be equal to effective resistance between A and B from infinity. So that also should be equal to R. Infinity up to CD you took as R. Infinity to AB also you should take as R. Infinity to AB means include this with AB, you are getting 2 plus R by 3 plus R, leaving out these 2. these two in parallel. First you find out effective resistance of these two. So 2 plus R by 3 plus R is equal to R. I repeat once again in case you didn't capture the idea. We are supposed to find effective resistance of the full network. Okay, out of that I'll leave out these two, 1 ohm and 1 ohm, because the repeated units do not include this. See, this 3, this 3, this 3, this 3, these two are left out. So repeated units infinity up to AB. So let's say it is R, capital R. Then infinity up to CD, removing this 1 unit, that is also R. So from infinity up to CD you take as R. Have this 1 unit mentioned here. Then this 1 ohm and this 1 ohm are here. Now R and 1 in series in parallel with this. So that will be 2 plus, this will be 2 plus R. This 1 ohm is in parallel. This 1 ohm and this 1 ohm is written. So now effective resistance between A and B, excluding this, will be 2 plus R and 1 in parallel. That is from infinity up to AB. That also should be equal to R. So simplify. 2 plus R, 3R plus R squared. So R squared, this R will go to the other side, it becomes 2R. R squared plus 2R minus 2 is equal to 0. So find R from this. When you find R is equal to minus 2 plus or minus root of B square, 4 plus 8 by 2. Minus 2 plus root 12 by 2. That minus root 12 you leave out. Minus 2 plus root 12 by 2. Root 12 has got 4 into 3, that 4 you take outside, it will become 2. So this will be minus 1 plus root 12 is root 12, root 4 into 3, that 4 you take outside, it will become 2, 2 and 2 will cancel. Whatever is there inside, that will be root 3. Root 3 minus 1 plus these two are there. So root 3 minus 1, 1 ohm and 1 ohm. This is 12 volt, 0.5 ohm. So root 3 minus 1 plus 2. So root 3 plus 1. Therefore effective resistance 1 plus root 3 ohms. All the way from infinity up to this point. So current from the battery. You need current from the battery. I is E by 12 by 1 plus root 3 plus 0.5 internal resistance. So I is equal to 12 by 1.5 plus root 3. Okay, simplify. On simplification you will get this as 3.7 ampere. If you simplify, you are getting 3.7 ampere. That is the current drawn from the battery.